Hello, lovely people. How are you doing? Welcome back to a video where we are looking at trigonometric identities involving sec, cosec, and cot. Right, let's get into it. So before I start, I'm just going to write down the identities that we will be using. So we've got 1 plus tan squared theta is identical to sec squared theta. And we've also got 1 plus cot squared theta is identical to cosec squared theta. Okay, so there are also, of course, the other identities, which are sine squared theta plus cos squared theta is 1, and sine theta over cos theta is tan theta. So with this one here, I am just needing to pick which side I'm going to start with. Actually, yeah, I'm going to start with this side. So I'm going to start with the left-hand side and aim to get to the right-hand side to prove that they're equal or they're identical to each other. So the first thing I can do is write cosec A and replace sec squared A with 1 plus tan squared A, because we know 1 plus tan squared is sec squared. So that's 1 plus tan squared A. Okay, and now if I multiply things out, I get cosec A plus tan squared A cosec A. So the reason I did this was because I could see that when I expanded, I'd get the cosec A on its own, as I have here, and then somehow I just have to manipulate this part to make it look like tan A sec A. Well, tan squared A is the same thing as sine squared A over cos squared A, and cosec is the same thing as 1 over sine A. Therefore, this becomes, cancelling the signs, or one sign at the top and then the sign at the bottom, I'm left with sine A over cos squared A. And that is the same thing, or I should write it down here, that's the same thing as sine A over cos A multiplied by 1 over cos A. Now you might think, why have I chosen to do that? Again, I'm always looking at what I'm trying to prove. What I'm trying to prove. So the second part, and this is of course plus cosec A. So before I say what I'm going to say, I'm just going to put plus cosec A. So really, I should write that bit here too. So I've got cosec A. Okay, so the sine A over cos A is the same thing as tan A, and the 1 over cos A is the same thing as sec A. So I just have to write that. So that's the same thing as cosec A plus sine A over cos A is tan A, and then the 1 over cos A is sec A. That's it for that question. We've proved that the left-hand side is identical to the right-hand side. Just got those identities there at the bottom. Right. Next, we have sec theta minus sine theta times sec theta plus sine theta. And we want to show that that is equal to tan squared theta plus cos squared theta. Well, this is a difference of two squares, something minus something, and then in the other bracket we've got the same something, but this time plus. So this expands to sec squared theta minus sine squared theta. Now, already we can see that our thing has tan squared and cos squared, but we have sec squared and sine squared. Well, we've got the identity 1 plus tan squared is sec squared, so I could change this sec squared to 1 plus tan squared. That works. And then the minus, well, I've got the sine squared, which using the sine squared plus cos squared is 1. I can change that to 1 minus cos squared. So now I've got an expression with tan squareds and cos squareds, so things must cancel out. So if I just write that properly, I've got 1 plus tan squared theta minus 1 minus cos squared theta, which is plus cos squared theta. So the 1 and the minus 1 cancel, and I'm actually just left with tan squared theta plus cos squared theta. Cool. Next, by the way, that's that question done. Next, we have, given that 3 tan squared theta plus 4 sec squared theta equals 5 and theta is obtuse, find the exact value of sine theta. Okay, this is interesting. This doesn't look like it's the questions are related in any way, but what I can do is, I know I'm trying to work out sine theta. These seem to relate to the 1 plus tan squared theta is identical to sec squared theta. If I can get everything in terms of one of those, I could then use that fact to then work out what sine is. If that didn't make sense, do not worry, we're going to go through this. So first of all, we need to simplify this. So I have a choice. I can express things in terms of sec squared, or in terms of tan squared. Do you know what? I think I'm going to go for this in terms of, let's go for sec squared, and I will explain my reasoning after. So tan squared must be the same thing as sec squared minus 1, just rearranging this identity. So therefore, I can write 3, not tan squared, but sec squared theta minus 1 plus 4 sec squared theta equals 5. Then I expand the bracket, I get 3 sec squared theta minus 3 plus 4 sec squared theta equals 5. Expand, oh, not even expanding, simplifying, is 7 sec squared theta minus 3 equals 5. Adding 3 to both sides and dividing by 7, I get sec squared theta is equal to 8/7. So now at this stage, what I'm going to do is rewrite this as 1/cos squared theta equals 8/7. Then I can find the reciprocal of both sides. So this one just becomes cos squared, and this other one becomes 7/8. So cos squared of theta is equal to 7/8. Now, using the fact that sine squared of theta is the same thing as 1 minus cos squared theta, I can say that sine squared theta is equal to 1 minus cos squared theta, which is 7/8. So therefore, I know that sine squared of theta is equal to 1/8. Therefore, sine of theta is equal to the square root of 1/8. Question is it the positive square root or is it the negative square root? That's the one that we need to figure out. And we know that theta is obtuse. So obtuse means between 90 and 180 degrees. So 90 is less than theta, which is less than 180 degrees. Either you can take your calculator out and go sine of some angle between 90 and 180. I'm going to use the graph because I'm not using a calculator right now. So this is a sine graph, got 90, and this bit is 180. We can see that between 90 and 180, our graph lies above the x-axis, so it's in the positive region. Therefore, it is indeed the positive square root of 1/8. And that's about what we need. So that's it for this video. See you in the next one. Take care.